Welcome everyone to the first episode of Mapaholic. Today, we're going to go over some Python basics, and we're also going to show you how to install Miniconda, how to install PyCharm, and how to write a very basic introduction script. So let's go ahead and get started. The first thing you're going to need to do is to open a browser and search in your favorite search engine for PyCharm. Go ahead and download using the download button at the top, and then download the community version of PyCharm. PyCharm is going to be the development, integrated development environment that we're going to use, or IDE that we're going to use to write our Python code and run our Python code. It makes it really easy in kind of a graphical user interface to write your Python code and run it, as well as kind of organize your projects, files, your various Python scripts and whatnot, all in one package. So there are many other IDEs, but this is the one that I prefer. So if you prefer a different one, please feel free to use that one. But in this case, we're going to be showing how to use PyCharm. Once you have that downloaded, go on over to another browser window and search for Miniconda. So you will see results similar to this. So just kind of click on this first result that should come up. And here you can, make sure you obviously meet the system requirements, but then go ahead and download and install Miniconda. So we're going to go ahead and take a short break, and when we come back, we will I'll walk you through installing these two programs. Welcome back. So hopefully you were able to download both the Miniconda installer as well as the PyCharm installer. So first, let's go ahead and install Miniconda. So here we're going to just, browse to your downloads folder. In this case, I just put this on the desktop so that it would be easy to find for this video. So go ahead and start your Miniconda installer and just kind of walk through. In this case, I'm just going to install it just for me. I'll just leave the default installation folder. And go ahead and skip this for now, these two options. And this might take a second, so I'm going to, we'll magically skip ahead to when this is complete. All right, so here we are, we're back, and Miniconda is finished. So I'm gonna not do these for now, but we're good. So now Miniconda has been installed, and the next thing we can do is go here to our PyCharm installer, and let's get that going. Prompting me for some admin credentials, and I'll bring this over here. So, this is pretty standard stuff. I'll just leave it in the default, location to install to. You can obviously change that if you would like. And then I'm gonna, add a couple of these optional choices here. The first one's going to be to create a desktop icon because I like to have that personally. You don't need it. I'm also going to choose to add this context menu. So that's like if I was to right click a folder, it would give me the option to open a folder as project, meaning a Python project. Or sorry, I apologize, a PyCharm project. And then finally, I'm going to also check this create associations with .py, so that any of my Python files which end in the extension .py or .py, though any of those files, if I was to double click them and try to open them, they would automatically by default open with PyCharm. So once that's done, I'm just going to go through the next pages, and we will skip ahead to when this has magically installed. All right, so we are back, and our PyCharm has finished installing. So go ahead and hit the finish button. So now that we have installed Miniconda as well as PyCharm, we got to do a couple things. First, we're going to create a Conda environment. So a Python environment is essentially, you can think of it as a workspace. It's referred to as an environment, and what you can do with a Conda environment or a Python environment is install various packages. So Python is kind of based around packages. So packages are essentially different software code that people have written and published for other people to use. So there are a myriad of different Python packages out there that exist, and there's going to be a few that are of interest for GIS people, geospatial analysts, or remote sensing folks. But so the first step is to create an environment. You can the beautiful thing with Conda is you can create as many environments as you want, and each of these environments you can have set up specific for a specific project with specific packages required to run that project code. You can also have just another environment just for playing around in, whatever you'd like. But for now, I'm going to show you guys how to set up a Conda environment and how to install some packages in there. So the first thing you're going to want to do is go down to your Windows icon, assuming you're using Windows, and search here for Anaconda. And what you should see, don't mind these Anaconda 3s, because I do also have a separate full Anaconda install, but don't mind those. What you really want is make sure it says Miniconda. You shouldn't have all these unless you also have another Anaconda installed. Same with Anaconda Navigator. Miniconda does not come with that. So that's kind of a GUI interface that allows you to create environments and things of that nature. But I think doing it this way is a bit simpler, and if you learn how to do it, it's really powerful and quick. The command line is what power users use, and at first it's a little intimidating, but it's not super difficult to get some of the basics down. So what you want to do is look for the Anaconda prompt. So once you find that, click that, and it always opens in the other screen, but here we go. So here what we have is an Anaconda prompt. So this is essentially running a command prompt terminal using your Anaconda install. So just to kind of show you guys, one command we can run is where Conda. So that will show you where this install of Anaconda is installed. In this case, Miniconda. So as you see, it's users and then my account username and then Miniconda and so on and so forth. So the first thing we're going to want to do is to create a environment. So it's very simple. You simply will type Conda create a dash and an N, and then the name of your new environment. So in this case, I'm just going to be very simple and name it Pi39 because we are going to make a Python 3.9 environment. So there are different Python versions. In this case, we're going to use one of the latest versions, which is Python 3.9. So to indicate to Anaconda what Python version you want this environment to be, we're going to then add the argument of Python equals 3.9. So what this is saying is Conda create an environment with the name Pi39 and use the Python version of 3.9. So once I go ahead and run this, you will see Conda will do some stuff. It's basically telling you that this is going to be the location of the environment. So Miniconda folder, then envs, so environments folder, and then its own folder of Pi39. So then it's telling you, we're going to download these various packages. These packages are going to be installed. So it lists all the packages and then the versions and whatnot of these various packages which are going to be installed. So it's asking you, do you want to proceed? So in this case, we can just type Y for yes and hit enter. And then it goes through and actually downloads and installs those packages for you. So it might take a couple minutes, depending on, your internet connection, your computer specs, but it shouldn't take super long. So then it gives you some very helpful tips here, and it shows you how to activate your environment. So once you've created your Conda environment, what you can do is you activate it. And once you activate it, you will essentially go into that environment. So into that, that workspace, you can think of it as. And once you're in the workspace, then you can install packages and you can do things of that nature. And you can also run Python code directly in the Anaconda prompt terminal. So let's try it. As you see here, in my case, since I named it Pi39, the command is going to be Conda activate Pi39. And one thing I want you to pay attention to is right now, you see at the beginning of the line, it shows base. So that's indicating that you're at the base environment for your Anaconda install. But once I run this, watch what happens. You see that changes to Pi39. So that indicates now we are in our Pi39 environment that we just created. As you can see, I went ahead and cleared our terminal. And you can do this by using CLS and then hit enter, and it'll kind of clear what you have in there. So the first thing I'll show you is how you can enter a Python environment. And to do that, you would just hit Python, type in Python, and then hit enter. As you see, it starts Python version 3.9.13. And so now you are actually in a Python environment. So you can do things like you could print something specific. You could do some basic math. 1 + 1 returns 2, things of that nature. You could also store variables, so x equals 1, y equals 2, x plus y, it's going to return 3. Things like that. But what that's one way you can run Python scripts. However, in this case, it's great for doing kind of one-off things sometimes. But if you really want to develop Python code that you can reuse, the terminal is not necessarily the way to do that. The command prompt. Sorry, I used the word terminal, command prompt. It's essentially interchangeable, but there might be some very small technical differences. But if you hear me say terminal or command prompt, it's essentially the same thing. So to exit the Python session, what you can do is just type in exit with some parentheses, and then you see it kind of exited the Python session because you can tell, because when we were in the Python session, number one, you weren't getting this every line. You weren't getting kind of our the folder we're working out of, the directory, as well as our Python environment, and the three kind of arrows facing that way indicates that you're in a Python session. But now we exited it, so we're just back up into our Python environment. So yeah. Next, I think the thing we should do is probably open up PyCharm and let's start using it. So the first thing, obviously, go down here, PyCharm, choose that, and it will open. Let's go ahead and minimize that command prompt. So once PyCharm opens, as you see, I already have an old project open, something I was doing for school. But let's go to File, New Project. And then here, let's do, let's, browse to the location on your computer that you want to, essentially a folder that you want to use as your project folder. So this is a folder where you're going to put all of your Python files and things of that nature for this project. So in my case, it's on my desktop and it's a folder called scripts. So I'm going to set that. And then next we're going to need to set a interpreter. So an interpreter is essentially, you can think of it as you're telling PyCharm when I want to run a specific Python script that you've written in PyCharm, or that was written elsewhere that you're trying to run in PyCharm, which Python environment to use to run that script. So that's what an interpreter is. So essentially what you have to do is you have to go down here to previously configured interpreter, because what we did is we already created a Python environment. PyCharm does also allow you the ability to create an environment through PyCharm, but I prefer to create it as you saw previously using Conda. However, don't mind this. This is another environment that I created with also called Py39, probably bad practice, but this was in my other Conda installation, so don't mind that at all. But what I'm going to do is go over here to add interpreter and then add local interpreter, and you have to make sure that you select here existing, not new, because if you hit new, it's going to be essentially creating a new interpreter. But what I want is an existing interpreter. So because we already created it. So over here, then it says no interpreter. So click the little three dots, and then what you need to do is browse to the location where we created that Conda environment. So in our case, it was actually in C users under my username, and then in Miniconda 3 folder. So if I expand that Miniconda 3 folder, and I'll give you guys a second to just catch up, but you know, wherever you installed Miniconda is essentially where you need to go. You know, the default location was the C drive, and then users, and then Miniconda folder, but you could have chosen a different location. So once you've found that Miniconda folder, you need to scroll down until you see this python.exe file. So it's going to have a little question mark by it, a little piece of paper with a question mark. Don't worry about that, but just single click that python.exe file, and then what you can do is hit OK. So when I do that, you see it set the path to that python.exe folder. Oops, I apologize. That is very much incorrect. What we wanted, so that's your base Python environment for Miniconda. Remember how I showed you back in the terminal how there was a base environment, and then when we entered the environment we created, Py39, there was that's the Python 3.9 environment that we created. So I tricked myself there, not paying attention, but it's a good learning lesson where this is not the one you want. So this is your base environment. You could use that, but it's good practice to leave your base environment untouched, and then to use the environment we created. So in that case, you're going to go to Miniconda 3, and then go to the envs folder. Once you're in the envs folder, you should see Py39 folder, which is the environment you created. If you create subsequent environments, separate environments within Miniconda, you will see their folders listed here as well. But in our case, we only have the one. So once you expand Py39 folder, then you'll see the same thing if you scroll down, where you'll see this python.exe file. So hit OK, and then now you see it set the correct path, which is, you know, your username, Miniconda, envs, Py39, and then the python.exe file. So that's going to tell PyCharm to use that Py39 Python environment. So once you've set the correct path, then hit OK, and you should see it updates here. And then all you got to do is hit create. And then, so it might ask you, do you want to open the project? And then I'm just going to hit this window because I wanted to open it in this window. So as you see now over on the left panel, you see your project kind of file browser, in essence, your project tab. And over here, since there's nothing in the folder, it's empty. But you also see like external libraries, and then scratches, which, you know, we could touch maybe in a later video. But for now, you just need to know that you see your scripts folder over here. So you can essentially interact with this similar to how you could, you know, a Windows file browser or what have you, where you will be able to essentially, what we're going to do, the first step is we're going to right-click this folder. So over here in the project pane, right-click that folder, go to New, and then go to Python file. So that's a very quick, easy way that you can create a new Python file in that folder, in your project folder. So hit Python file, and let's name it Learning 1. You know, you can name it whatever you really want to name, but all you got to do is type in a name and then hit enter. And as you see, it automatically creates you a learning_1.py file, and it automatically opened it, which you see it added this new tab here, and which will allow you to type in your Python script. So now that we have the new Python file created, let's go ahead and write some very basic code, and I'll show you how to run it. So one of the first things you always learn when first diving into Python is going to be a print statement. So a print statement is essentially going to tell the Python code to write whatever you put inside of the print statement to and output that to the terminal. So as you can see, we don't really have a terminal, but what you will see is that when you run the Python script, PyCharm will open up a little kind of box at the bottom, which essentially represents the output that you would get in a terminal or a command prompt. So the most simple thing you can do is just a very basic print statement. And to do that in Python 3, you simply write the word print. Then in parentheses, you can put various values. For instance, if you had a variable with a string contained within it, then you could just write the name of the variable. But in this case, we're just going to put a double quotes. And the nice thing is, one wonderful thing about PyCharm is what you saw. Let me show you again. When I put, all I have to do is type the first parenthesis, and it completes the second one, because it intelligently knows, hey, he's going to need two parentheses here, a beginning and a closing. So it automatically adds the second one. And the same thing goes with quotation marks. If I'm going to write a string, so strings go inside of quotation marks. If I write the first one, all I have to do is put a single quote, and it automatically adds that second one. So what I can do here is just write a pretty cheesy joke, but geography is where it's at. So when I go ahead and run this, you'll see that it's going to write this string out to the prompt. So there are a couple ways to run a file. The first way, if you had multiple Python files open, you could use this drop down to choose the specific file, and then hit the run button up here. So it says run learning1.py. So that signifies it's going to run this Python script. An alternative way is to right-click this tab header. So where it says the name of the file, the tab, right-click it, and then you also see here run learning_1, which is referring to the script we just wrote. So let's go ahead and run this and see what happens. Boom. So what you see is it opened this kind of run dialog terminal where it can print out results. So essentially what you see here is if you were to run this in a command prompt, you could certainly do so. And this would kind of be the syntax to do that. Whereas you would first point the terminal to the specific Python environment that you're using, and then you would separated by a space, you would then put the path to the specific Python script that you want to run. So that would be the syntax. You could actually copy and paste this exact syntax into a command prompt, and it would run this Python script just as it does here. But then what you see is the results of our print statement. Geography is where it's at. So you see that it worked. And another way to tell that the script ran without any errors and successfully completed is that you see it says processed finished with exit code 0. So exit code 0 is great. That's what you want to see. Exit code 0 means that there were no error codes. 0 error codes essentially came up. If you see anything else other than this, there were issues. There were errors. Something went wrong. Let me see if I can show you that. See how another great feature of PyCharm is that if you miss very basic syntax issues, it can catch that. Very similar to like a Microsoft Word or word processor, where it kind of gives you red squiggly underlining where there's spelling errors or stuff like this. And PyCharm gives you very useful hints and tips. And as you see, if I hover my mouse over it, it says it's missing the closing quote. So it knows intelligently, like, hey, this is supposed to be a string, but he only has the one quote. It doesn't have a closing quote. So I'm going to leave it like that, and let's try running it and see what happens. And as you see here, now you get some red writing, and what you see is that essentially it threw an error, in this case a syntax error. So it said that when it was scanning this string literal, that there was an error. So basically we know what the error is, and we would just have to add our closing quote again and then run it, and it would run successfully. But I just wanted to show you what it looks like when there's an error. So now that we have an extremely simple Python script run, let's try something different. So I'm essentially assuming that if you're watching these videos, you have some basic Python knowledge. Essentially, in terms of, I think it would be very beneficial to run through, something similar to like a Code Academy. Maybe some of the first few lessons in Code Academy for Python. It's completely free. And again, we're not sponsored by, Code Academy, but there's other, free tutorial websites out there, but Code Academy is just one that came to mind. So, something similar to Code Academy to kind of learn some of the basics. I would call them the vocabulary terms. In this case specifically, like, what is a variable? So I'll briefly describe what a variable is. A variable is essentially an object that you can store information in, and then you can recall that information by simply calling that variable again. So for instance, I'm gonna create a variable called my variable, and then so it has to be a one word. It can't have spaces. So I can use an underscore. You can also use what's called camel case, where you would go like this. I kind of prefer underscores. I think it's a little bit more readable. So I'm going to say my variable, and then you do a space, and then the equal sign, then another space, and this is where you're declaring what your variable is equal to. You're setting the value of your variable. So in this case, let's just set it to an integer of 1. So I'm going to say my variable is equal to 1. And then I'm going to say your variable is equal to 5. And then here we can say, and this is another great thing about PyCharm, is instead of having to type out that entire variable name manually, when I type in it looks through the list of variables or other objects, and it says, hey, you've got a variable that starts with my, so I'm going to put this in a list. So all I have to do is start typing it, my, and you see it comes up. And if I go back, it gives you other options that start with M, and I can just use my arrows on my keyboard to scroll through those. So once you see there's a yellow circle with a V that represents a variable. So when it says that the variable named my variable is highlighted with the blue highlighting, then I can hit enter. And as you see, it fills that in for you. So you don't have to type out my underscore variable. It's a pretty nifty shortcut that comes really in handy. So here I'm going to say my variable plus your variable. And what I'm going to do is I'm going to set this equal to another variable. So I'm going to create another variable called the answer. The name of the variable is answer, and I'm going to set the variable answer equal to my variable plus your variable. So now that we have that, I want to see what the answer is, right? So we're going to use a print statement, and we're going to print out the answer. Cool. So now when I run this code, we're going to store the integer of 1 into my variable, the integer of 5 into your variable. The answer is going to be equal to my variable plus your variable, and then we're going to print the answer. So let's run this and see what happens. Boom. So what you see is the answer is 6, because 1 plus 5 equals 6. So that's just kind of a quick way of going over some very basic Python topics and kind of Python 101, including variables, and then also data types. Data types is a very important thing, especially in GIS, remote sensing. Data types comes up a lot. So, for instance, there's integers, there's floats, things of that nature. So, an integer is a whole number. So as you see here, 1, 5, 100, a million, whatever, a whole round number. There's also floats. So a float would be float variable equals, so 1.5. So float is essentially a decimal, a number with a decimal, not a round, not a whole number. Sorry, I didn't mean round, not a whole number. There's a number of other different data types, for instance, strings, which we already saw. So for instance, I could set name. I could create a variable called name, and I could set the name of that variable to a string with my name in there. My name is Dan, so I'm gonna set that variable to the name of Dan. So what I can do here is I can say print name, and what's gonna happen here is it's just gonna print my name. So variables can be set to a number of different data types. And data types, variables, things of this nature are things that you would learn if you were to go through some of the Code Academy stuff. So next, we're going to look at a very kind of simple Python script that I have that we're going to write together. And what it's going to do is it's going to reproject a shapefile, which is a very common task in GIS world, reprojecting a shapefile from one projection to another. So we're going to use some a Python package called Shapely to do this. So, coming up next, that's what we're going to do. So the next thing we're going to have to do is to install the package that we're going to use to write our next script. So I want you to go back to the Anaconda prompt that we had open before. If you happen to close it, I'll show you the process again real quick. It's came here, but so Anaconda prompt, make sure it's the Miniconda 3 if you have multiple Anaconda installations, but you probably don't. So open that up, and here, let's do Conda activate pi 39. Beautiful. So now we're in our environment. So what we want to do is to install the package Geopandas. So Geopandas is a wonderful Python package which, if you're familiar with Pandas, so Pandas is another Python package that's very useful for reading and writing data sets. So specifically tabular data, which in essence you can think of like spreadsheets. So it's very useful for working with kind of spreadsheet data. That's, sounds boring, but a lot of data science and data sets come in kind of tabular spreadsheet format. So Geopandas essentially expands on that and enables you to essentially interact with and work with geospatial data. Many data formats, geospatial data formats, for instance, GeoJSON, shapefile, things of that nature, within kind of a pandas framework. So it's called Geopandas. So what I'm going to do is open up a browser, and then I'm going to go to search. So that usually if I need to install a new package, I will do a quick search similar to this. So Conda install Geopandas. So this is something you need to be cautious of, because if you were to simply type in, most likely it's Conda install Geopandas. Most likely. However, there are instances where certain packages, potentially, someone could, with malicious intent, could set up a package that's very similar to a real package, a safe package, and they could, it could be one letter off. There's other ways they can do it where you could potentially install stuff that you don't want on your computer, viruses, malware, things of that nature. So I think this is a very smart way to do it. Always go here, Conda install Geopandas. You can either go to, find the specific package website. For instance, they have a geopandas.org, so you could look at this, for instance, installation, and then it can show you the actual code, the command line that you would enter. But you could also, another good one is to go to anaconda.org, and you'll see Geopandas. So Conda Forge is kind of the repository for all Anaconda packages, Python packages. So that's kind of the official broker, one of the official kind of brokers for Python packages. So what we're going to do is we're going to go to here, anaconda.org. And as you'll see here, it also shows a number of different kind of command line, commands that you can use to install this package. So here it's saying Conda install, and it's using Conda Forge, which is the official package repository essentially. So what I'm going to use this one here, Conda install. So I'll just Control C that to copy it, and then over here in the command prompt, the Anaconda prompt, should I say, to paste into a terminal or a command line, you need Control Shift V, because Control V will simply, I'll show you. Oh, look at that. It actually worked. some terminals you can't control V into, so you'll need to control Shift V, but in this case it worked. Of course, making me eat my words, but potentially it could type in Control and V. So anyways, so you'll want to paste that in there. You could also, I guess, right-clicking also paste that in there. Okay, so let's just do that one more time. And so once you paste that in there, let's run that. And this might take a second. Sometimes it can take a little bit of time for it to, do this. So here it's going to ask, it's saying the following packages will be updated. It's going to install all of these packages. So that's the beautiful thing about Conda, is that Conda handles a lot of dependency management. So that's one of the reasons Anaconda was founded and created, was because using the traditional Python package installer, which is pip, oftentimes you'll run into really challenging dependency issues. So dependencies means that certain packages that you install also rely on other packages to function. So essentially they call it dependency because it's depending on the other package to work. So if you wanted to install one package that had dependencies on other packages, but you didn't also install those other packages and the specific version of the package that it needed, you can run into issues where stuff won't work. So what Conda does, Anaconda, or short, I keep saying Conda. Conda is short for Anaconda. So what Conda does is it's very, very good at handling those dependency installs. So what you see here is Geopandas is dependent on all of these various packages. And so it's saying it's going to install all of these packages. New packages will be installed, all of these. And then the following packages will be updated. So we already have some of these, but they're going to update to a different version. So the following packages will be superseded by a higher priority channel. So just basically you can ignore that, but I just wanted to kind of explain what's going on. So just hit yes, Y for yes, and then this is going to take a few minutes. So hopefully not too long, and we'll wait through it. But yeah, so that's one of the reasons I like Anaconda versus, you can install Python. There's nothing wrong with Python, but oftentimes I have found that Anaconda will work very well to handle dependencies. Yeah. So hopefully, this specific video will be a great jumping in point. And I know there's a lot of information, that I'm kind of going over, but hopefully it'll be a great jumping in point where you can kind of get your teeth wet and, get some actual useful coding done. Something that, you'll be able to potentially use in your daily job if you're, in the GIS world. Otherwise, it's just great, Python skills to know, how you might, access files and modify files and write files, things of that nature. So hopefully this won't take too much longer. think it's almost done here. All right, beautiful. So now as you see it finished, and you see this initial prompt come back up and tell you you're in your environment in this folder. So now that we know that Geopandas is installed, I'm just going to go ahead and minimize this again, and we will begin writing our script. So back in our PyCharm window, let's go ahead and so we kind of use this learning Python script to just kind of demonstrate how to run a script and some basic Python 101 stuff. But now let's go ahead and create another script which we will use to store our code to project our shapefile. So the first thing we're going to do here is right click our scripts folder again in our project pane, go to new, go to Python file, and let's name this project shape with Geopandas. Okay, so you can obviously name it whatever you want. I like to use descriptive language, concise but descriptive language to name my Python files and scripts, so that in the future when I go back and I'm looking for that one specific script, I'm able to find it easily, because no one likes to look through a bunch of script, wasting time looking for stuff. So I think being descriptive is good best practice. So hit enter, and then you see it automatically created a new script here for you. That's empty, it's blank. So the first thing we're going to do at the very top is we're going to have to import that new package. So importing a package is a process in scripting which, I apologize, my dog is scratching himself. But this is a process where we have to import the specific package. So we import it, and then that tells the Python script, like, hey, we're using this, kind of check it out of the library, so to speak. So first let's import Geopandas, and you see it kind of popped up there because it found that package while I was typing Geopandas. You see that popped up there, Geopandas as GPD. So that's kind of giving an import an alias is kind of a common technique used to make it easier. Instead of having to type out every time you're using it Geopandas, all you have to do is type in GPD. And since you say import Geopandas as GPD, you're kind of saying this is the nickname I want to use in the script going forward. Not of all time, like it's not saving this somewhere, but this is only for this specific script. So every time you write a new script and you want to import Geopandas as GPD, this is the way you would do it. So let's go to another line. So here, the first thing we're going to do, and let me show you the data set that we have. So I'll really quick open up QGIS so I can show you what I have here is a shapefile that I found, and I'll post the link of where I got this shapefile. Is essentially a US states shapefile. So I'm going to just drag this in drag this into QGIS real quick so that we can take a look at it. And what you see is that it even contains the, territories, some of the territories over here, Hawaii and whatnot. But essentially, it's all of the states and territories of the United States. And it's just a generic, shapefile, polygon shapefile. We can look at the attribute table over here. And you just see it has state names and things of that nature. But let's just say for our scenario, what we want to do is we want to reproject this into a specific projection. So let's check out what projection it's in. Go to the properties. And then I'll look over here and I see, okay, it's in NAD 83, so North American Datum of 83. And which is EPSG 4269. Okay, so I know what projection it's in currently, but let's say just for instance, I want to use this in a web map, and my web map is going to use the pseudo Mercator or web Mercator, so WGS84 web Mercator or pseudo Mercator projection. Let me pull this up, web Mercator. And I'll search that, and you can see it's this projection here, here. There it is. Okay, so yeah, I guess better known as pseudo Mercator, also web Mercator could be known as. So WGS84 pseudo Mercator, and we can see that the EPSG for that is 3857. So that's something we want to keep in mind going forward. So EPSG are if you're not familiar with it, they are codes that refer to a specific projection. So in this case, the projection we're interested in is 3857. So I didn't mention, but the pseudo Mercator projection is a projection that's used by, as you see, many large web mapping platforms such as Google Maps, OpenStreetMaps, Bing, etc. So it's a very popular projection for web mapping. So okay, so let's keep this in mind. And I just wanted to kind of show you guys that. So let's just, for our scenario, we're going to create a web map. And what we want to do is project our shapefile into that projection so that we can use it. And it'll match all of the other data layers that are going to go into our map. So what I have here on my desktop is a folder called data. And here we have our shapefile. So what we're going to need to do first in our Python script is to define a path to that shapefile. We need to refer to that specific shapefile on our hard drive. So what I'm going to do in my Windows Explorer window is obviously browse to where that shapefile is. And then one trick is if you hold Shift and you right-click the shapefile. So remember, you might know or you might not know, shapefiles also come with several other files that comprise the shapefile, such as the .prj, the dbf, the cpg, and the shx. So what you need to do is just make sure it's the shp or the actual shapefile. Hold Shift down on your keyboard, right-click that file, and then you can use this option called Copy as Path. So when you click that, what it did is copy to your clipboard the path to that file. So in here, let's go ahead and make a variable to store this path in. So let's call this variable states shp. So we know it's the states shapefile. So let's set that variable equal to our path, and all you have to do is hit Control V, and since you did copy as path, it will paste that path directly in there. So you don't have to type that out. It's a good trick to get the exact path to a specific file. Now, one good practice is if there happens to be a space in any of this. In this case, there isn't. They used, it's kind of hard to see because there's a squiggly, but they used good practice in terms of naming. And what they did is that it's screaming because it likes blank space at the end of the file. Okay. So yeah, here's a good example of why what I'm going to show you is useful. Because it's saying that there's an escape \d, which is an escape sequence in Python, which don't worry about what that means. But basically, if there's a space or there's some other thing in your string that Python doesn't like or kind of is reserved for something else, what you can do is put an R in front of it, in front of your string. And what R does is it's telling it it's a raw string. So R stands for raw, as in like raw meat, as an example of that. So what that does is it essentially, if there are spaces, as you can see, this all uses underscores, and it is good practice to use underscores versus spaces. I can't tell you how many times, spaces have broken things. In this case, there are none, but it's still good practice to just use the R before your paths in Python. So we set that. So now we have a variable with the path to our shapefile stored in there. So instead of having to write out this whole long path every time, all we have to do is call this short variable name. So we're also going to need, a variable that's going to store the output of our shapefile. Of our projected shapefile. But you know what? Let's wait on that. So the next thing we're going to do, let's skip down a couple lines just to kind of give a little buffer separating white space in between our kind of declared variable up there, our input variable, and what we're going to do next, our kind of meat of the code, so to speak. So the first thing we're going to do is we're going to read in the shapefile. So with Geopandas has a function called read file, which allows you to read in a file. So to use that, what we do is we're going to create another variable, and we're going to call this one states GDF. So GDF stands for GeoData frame. So in Pandas, Pandas has a concept called data frame. So when you read in a CSV file or a Excel file or what have you into Pandas, it reads it into what they call a data frame. And a data frame essentially is how Pandas interfaces with your data set. Now, Geopandas kind of took that idea and created what they call a geodata frame. So a geodata frame has not only essentially the interface to interact and read the data stored in your data set, but also it contains the geographic information. So there are you can define geographic reference and geographic locations of each feature in your data set. So GDF is kind of shorthand for geodata frame. DF is traditionally, you'll see it as used for many Pandas scripts, but for Geopandas they use GDF. So here we're going to call it states GDF for states data frame, and we're going to set that equal to Geopandas, so GPD. If you hadn't set an alias here, you would have to write out Geopandas, but in this case we did our shorthand, so GPD dot read. And this is another awesome trait of PyCharm, where it comes up and it shows you potential functions that Geopandas has assigned to it. So when you do Geopandas dot, that's referring to a function inside of the Geopandas class or package. So as you see here, it comes up with read file. So there's also read feather, read parquet, and read postgis, but this is something, those are not within the scope of this, obviously, and the one we're interested in is read file. So all I have to do is select it using the arrow here and hit enter, and it auto fills it for you, which is beautiful. So you know there's no typos, you know it's right. So read file, and then what you also see here is it comes up and it tells you the arguments for that function. You can also hold your cursor over that function physically, and what you see here is it's showing you the arguments. So what is in the parentheses are things that it needs to actually work. So for instance, you know, there's a file name function. I can't move my cursor, but there's a file name, there's the B box, so bounding box, the mask, rows, engine, etc. So what we're going to use is essentially the file name, and what we're going to do is we're going to input our states shapefile. So the path to our states shapefile. So what we're saying is Geopandas read our states shapefile and store that in a data frame in a variable which is gonna equal a data frame. It's essentially gonna create a data frame and store that data frame in a variable called states GDF. So now we've read in our shapefile. So one good practice is to comment your code so you know what you're doing. To comment in Python, you simply do a pound symbol, or commonly known as a hashtag. So you put your pound symbol, and then let's say read in the shape file. Okay, so now we know what that line is doing. So we're going to go down here to another line. White space is always good because it makes your code more readable. Having everything jumbled up makes it less readable. Okay, so one of the first things let's do is, before we looked in QGIS to try to see what our projection is, but Geopandas has a very handy method of reading and determining the projection of a file. So what we're going to do is we are going to use the .crs method, and that method can be called on a data frame, a geo data frame. So what we're going to do is we're going to print out our states geodataframe.crs, and what that's saying is I'm telling the script first read the file and then print me the CRS of that geodata frame. So print me the CRS of that data frame. So let's go ahead and run this right now and see what happens, and just make sure that everything is working as expected so far. Perfect. So what you see here is that our output is EPSG 4269. So if I was to go up here and I search EPSG 4269, I get what we saw in QGIS, which is NAD83. So that's a pretty nifty way you can check what coordinate reference system or projection our input shapefile is in. So just that's a cool little check we can do. So now that we see it is in 4269 or NAD83, the next thing we need to do is we're gonna essentially create a new geodata frame, and we're going to use a method called toCRS. So it's saying we're going to project it to a specific CRS. So this is pretty simple. We're going to create another variable, and let's call it states PRJ for projected GDF, geodata frame. So states projected geodata frame. So let's set that equal to the states geodata frame dot to C, and as you see it comes up CRS, and then in parentheses here we're gonna want as you see there's an argument for this function, which is EPSG. So let's set EPSG equals, and then let's go back to our over here. We already searched, so this is the one we want, 3857. So I'm gonna go down, go back to our script, and I'm just gonna paste in our projection, our EPSG number. So we have that. So what this is saying is create a new variable called states_prj_GDF and set that variable equal to states_GDF dot. So set it equal to the states geodata frame, but of that, with that data frame, change the, project that, convert that projection to EPSG 3857. So it's a new data frame, essentially, that replicates this one, except for it's going to be in this projection. So that's what we have, is a new geodata frame in the new projection that we want. So there's only one line of code left, and it's really simple. Geopandas has a very simple function to save a file out to a new, essentially export or save a data frame, a geodata frame, to a new file. So it's called explicitly to file is the name of it. So let's do this, and we're gonna say states PRJ GDF, so states projected geodata frame dot to CRS. You see it comes up, or sorry, that's not the one. To file, it came up there. So to file, and then what we're gonna want to do is we need to create a new file name. So at first I was gonna have you just explicitly create it up here, which you very much could. You could do something like this: states PRJ SHP, so you know it's the projected states shapefile. You could even just copy this, paste it over here, and then you could just modify the name to say PRJ, so you know that's the projected version. You could do something like that. There's nothing wrong with that. I'm going to show you kind of a more, a better way to do it. Because if you wanted to, for instance, make this into a loop, which is something that I'm going to do next, once we run this and see that it's working, the next thing we're going to do is make this into a loop so you can iterate over many shape files within a folder. So what we're going to do is we're going to dynamically get the name of the input file and then convert that name and just add _PRJ to the end of the input file name, and then use that as the output file name. So to do that, let's add some white space, and we're going to say projected shape. So the projected shapefile is going to equal the inputs shapefile, so states shape. And Python has a really cool method of replacing text within a string. So here we're going to say dot replace, and inside the parentheses. So as you see here, the formatting is the old string, comma, new string. So what you can do here is we can say, so this is what I want to replace. So in this case, we know that all of our shapefiles are going to have a .shp. So let's replace the .shp with, so we add a comma, and then this is what we're replacing. So this is what we want to replace. This is what we want to replace, and this is what we're replacing it with. So here, let's go underscore PRJ, and then we have to add back our .shp because we removed it before. So basically all we did is got rid of this and added this in there. So that's a really nifty way of kind of dynamically replacing and creating an output name. So what this is going to equal is this string, this variable, with this replacement done. This replaced with this. So now we can use this name to go in here and to say to file, and this is the file that we want it to go to. So we say prj.shp, and that's the end of the story. So what we could run this right now, and it would very much work. But let's add one more print statement. So here we had a print statement for printing this, the projection of the input file. So let's just make sure, like, one quick way to kind of test this out is you highlight it and you hit Control / or Control ? And what that does is it kind of comments that out, so it's not going to run. So any line that is commented will not run. It won't be processed when you run this file. So here we saved our new data frame, and let's just add a quick print statement. Print states prj data frame .crs. So let's just make sure that it actually reprojected to the new projection that we wanted. So let's run this. And we see that the first one, the input CRS printed to 4269, and then our output CRS printed to 3857. So it did do what we wanted. Okay, so like I said, it's always good to comment our things. So let's say create new geo data frame with new project. And one way we can make this script even more dynamic is let's set up here EPS new EPSG. So what this is going to be is the EPSG number that we want to project it into. So here we're going to set this to new EPSG. So what that's going to do is, instead of having to go deep into the script every time, if you wanted to use this script over, you could simply change it up here, and this will read it from here, if that makes sense. Yep, I think that makes sense. So cool. So Awesome. So let's try and see what happens here. So let's uncomment that, and to do that, it's the same exact button combination that I mentioned before, control question mark or control forward slash. So you can just toggle it on and off. Whatever is highlighted will be commented or uncommented. So let's uncomment that again, and then let's add some comments so we know what's going on down here. So here we are creating the output shapefile path, and then here we're saving the projected data frame to a new shapefile. Awesome. So now anyone else who looks at this code will know what is going on. And let's even comment some of these input parameters or variables. So here, the shape file you want to project, the EPSG code of the projection you want to use. That wording could probably be improved, but and then what I oftentimes like to do, just formatting a script, it really helps me visualize where the parameters are versus where the script begins. The actual process of the script is I just put a bunch of pound signs here that it kind of separates the input parameters. So every time you run the script, these are the things that you're going to want to change. Everything else can stay the same and it'll still run properly. All you have to do is change these. So if you want to reproject a different shapefile, you just put the path in there and you can change the projection here without messing with any of this stuff. So that's kind of the basic formatting here. So let's try to run this and see what happens. Let's all open this folder so we can watch. It'll probably go away when I click that, but let's hit run and it's going to go really quick. So here we see it printed the two EPSGs here that we have. And then if we go to our folder, we can see that there is now a new shapefile in here with the underscore PRJ. And so let's go back into QGIS and let's bring this into QGIS. And let's, yep, okay, so I'll just cancel that. Because it was asking, it recognized that it was a different projection. And now what we're going to do here is we're going to go into the properties and we are going to have to cancel that again. So now we're going to go into the properties and we're going to see that it is projected into the new projection that we wanted, which was 3857. And I apologize again for my dog over there. But yeah, so it reprojected it into the new projection here. WGS84, pseudo Mercator, EPSG 3857. So it worked. Beautiful. Awesome. So now you have officially written your first Python script that you can reuse and project shapefiles relatively easily and efficiently. So now what we're going to do is we're going to quickly try to convert this script to work on an entire folder if there were multiple shapefiles in that folder. So currently you have to input a single shapefile and then it outputs a single shapefile. But what we want is, oftentimes, and that's kind of the power of Python. Most people could just use QGIS to easily do this, this process to reproject, or, you could use ArcMap or whatever your favorite GIS software is to easily reproject a single shapefile. And those softwares also have quote unquote batch options, which let you do multiple shapefiles. But, obviously we're trying to learn Python here. So what we're going to do is we're going to show how to essentially do a batch process. How do you go through an entire folder, which could contain, 5, 10, 20, 50, 100, 1,000 different shape files. And how do you project all of those? So, currently, like I said, this is set up to only work for a single shapefile. But what we're going to do is we're going to do a process and a concept in Python called a loop, or in this case, a for loop. So what a for loop does is you essentially create an iterable object, an object that you can iterate through. So an iterable object can be different things. One of the most common would be a list. So a list is another kind of Python object, similar to a variable. So what we've been using here are variables. So you can define a variable which can store, information, but a list is just a different type of object. So a list is formatted as such. My list equals, let me give us a little space to work with here. So my list equals, and then you use square brackets. So it would be item 1, item 2, item 3, etc. So that would be a list, and they're squiggly red underlined because these do not exist yet. But you could have it as strings as well. So you could have item 1, item 2, item 3. So that's a list. It's a list of items in that case. So a for loop would say, for each item in this list, do this. So first it does what the process you set out for it on the first item, and then when it's completely done with that process, it'll go to the second item, and then it does that whole process on the second item, then the third item, and then the fourth, etc., through the whole list of items. So that's kind of what a for loop does. So first what I'm going to do is I'm going to show you guys a different package that comes with Python installed, and it's called glob, Glob. So what we're going to do is we're going to import, we need to say from glob import glob. So you could simply just import glob and it would work, but then every time you call, so glob is a function of the glob package. So every time you would run it, you would have to do glob.glob. But if you say from glob import glob, all you have to do is say glob. You don't have to do glob.glob. I know that's very confusing and it doesn't really make sense when you first hear it, but trust me, it's easier this way. From glob import glob. So let me pull up a thing here. So I go to my GitHub here, and I'm going to show you. So on this GitHub, I will also post this script, just FYI, so that you can just download the script. And and you can see, you know, what, you can just download the script and easily use that. So what I did is I just went there. I had already written this, so it makes it easy to just copy and paste. And that's what all good programmers do, is why reinvent the wheel trying to rewrite the thing when you already did the thing, so to speak. So, so I copied this and pasted this here. So what this is going to do is you're creating a variable that's going to store a list. So what glob does is it creates a list. Before I manually defined a list, but in this case, it's just going to create a list. So in folder is a folder that was in the other script. But what we're going to do here is we're going to comment this out. So we don't need that variable anymore. And here we're going to have in folder. So let's create another variable called in folder, and we're going to set that equal to this folder. Okay, so currently there are two shapefiles in that folder, the original one and the one we already projected. In that case, what we can do is we are going to, we set it to just that folder. So we don't have to set it to a path to a specific shapefile in that folder. We just set it to the folder itself. So that's going to be our folder. So here we're just going to change this. It was slightly different formatting here. So in folder. So what this shape list is going to be, glob is going to look in the in folder. So it's going to say in the in folder, then look in the in folder for the asterisk means all. It's a wildcard. It says it doesn't matter what's in front of this. Oops. So whatever is in front of shape.shape, it doesn't matter. Just get everything in this path that contains dot shape at the end, essentially. So you could change this if you wanted to get all the CSV files or all the, doc files or whatever have you. In this case, we want shape files. So that's what this is going to do. So really quick, let's try to comment all of this out, and let's say print shape list. This is a really good way of kind of debugging. You may have heard of a thing called debugging. Debugging is kind of a way to work through your code and make sure step by step that everything's working. This is kind of a dumb debugging method. There's much, PyCharm itself has a debugger, which is very much out of the scope of this video, but it's a very useful thing, and I would recommend looking into that. But for this case, we created our list of shapefiles, what we think is the correct list of our shapefiles. So let's just print out that list and see what we get to make sure that we have the correct output. So when we run that, what we see is it prints out, like I showed you, square brackets. So we get square brackets, and then inside the square brackets, we have our first shapefile inside of a kind of a single quote, so a string containing that shapefile's path. As you see, that's the first shapefile, and then our second shapefile here is the already projected shapefile. So here you see this is the second one, and it's the one with the underscore PRJ in it. So that's the second projected shapefile. So basically it's a list of the shapefiles in that folder. And it's separated by a comma. So it did produce the result that we wanted. So that's great. So now we know what we have is a list of all of the shapefiles in the input folder, right? So next, what we're going to do is we're going to create a for loop. Before I kind of described a for loop, but now we're actually going to create it. So the first thing is we're going to say for, literally for, so for, let's call it shape, and this can be anything. This declaration, this word can be anything. I could call it, you know, dingleberry. It doesn't matter. Some people like to use like a single letter, like I or X or whatever. I like to try to use something relatively concise, but something a little bit more descriptive than I. I is usually a very go-to like iteration for iteration in the list. But in this case, let's just go for shape in shape list. Then you say semicolon. You put a semicolon. So this says for shape, for each shape in the shape list, there's a semicolon. It says, essentially the semicolon is do. When you hit enter here, PyCharm is smart, and what it does is it indents. So it's 4 spaces, 1, 2, 3, 4. So 4 spaces is what it would put, and that's the Pythonic way of saying that everything that is indented below this for statement line, so everything indented below this line is what we're telling it to do. It's the way that Python will know that that's what we want to do. So what we want to do is let's uncomment this, and if you have it highlighted and you press tab, it will indent stuff for you. You can press tab again and it'll keep indenting it 4 spaces every time. Or you can hit shift tab and it'll unindent it 4 spaces. So that's a really good shortcut. Highlight it all and hit tab and it'll indent it for you. So now that we have all of this stuff indented, so technically right now it says for each shapefile in the shapefile list, do this stuff. So it would attempt to run this stuff for each of the items in this list. However, currently the way it's set up to run for one specific one specific shapefile, as we have the script before. So what we have to do is modify stuff just a little bit in order to get it set up to run with this for loop. So to do that, let's first go ahead and, so let's think about this. So first we're reading in the shapefile. So what we need to do is, so when we use the for loop, whatever we put in here becomes how you can refer to the item in the list in your process. So what I would need to do is take this SHP and replace it here. So instead of this shape variable, we're now using this SHP iteration. So this SHP represents the item in the list that we're actually on in our loop. So when I replace that there, so if you see, another cool thing about PyCharm is that when I click on the item, it shows other places in the script where it appears, that item appears. So if I click that shape, you see it appear here. If I click this shape list, it also appears here. So you can see, or vice versa. Like if I wanted to see like where the heck, if this was many lines of code, where the heck did I define what this shape list is? it'll highlight it here so I can go back up. Oh, okay, shape list is that. That's what shape list is. So for here, for this, it says shape, and now you can see that this is what shape is. So for each shape file in the list, read in that shape file. Then, okay, so we're still going to print our coordinate reference system, or our projection of that shape file. We can still use this. So what we're going to do, so we still have this as a variable that we defined up here. As you can see, it's highlighted. So we can leave that the same. And then this we need to change, because here we were referring, as you can see, it's squiggly line underlined with red squigglies, because it no longer exists. When we commented it out, it kind of went, it took it out of the memory of PyCharm saying, hey, I know what this is, because when it's commented out, it doesn't know what it is. It doesn't look at comments to find variables. So here it's saying, I don't know what this is. But what were we doing? We were creating the output shapefile path. So here we're going to say, okay, instead of that state shape, the same thing we did here, we're going to need just SHP. So we're lucky and we already have SHP, which is short for shape. So for each shape, we're going to read in the shape file. We're going to create a new data frame of it with a new projection. And then we're going to create an output shapefile path with the name .prj, replacing the .shape with _.prj. And then we're going to save that shapefile to to the path that we defined here. So this will now work to loop through every shapefile in this folder and then project it. So let's run this. It might cause issues. I guess I didn't think this out too well, because I should have gotten another data set to practice with this, but here we go. Let's try it and see what happens. Worst case is it breaks. Awesome. So as you see, it went through here, and it did it once, and then it also did it again, because you see it in this case, it's not a great example, again, because it already had that projection, and it just projected into the same projection. But, what we can do to make this a little bit more readable is there's a couple things. One, we could put, some more descriptive print statements. So we could say, print, let's put a string here, and let's say input projection plus that. And then here we could say output projection that plus that. So that's going to print this string, and then it's going to print that. Let's put a space. Okay, so it's going to print this string, and then it's going to print the results of this. So let's run it again and just see the result of just adding that. And ignore that. Well, that's good, because I was going to show you a better way. There is, in fact, which we might need to install it. So let's go back here really quick. I know this is getting long at this point, but really quick, I want to show you TQDM. So TQDM Here we go. TQDM is a really easy and cool progress bar. So it's a way you can add a progress bar to your for loops. So instead of looking at, what you saw before, you'll get a really pretty progress bar. So what I did is I went to Anaconda, Conda Forge, TQDM, and I got this official install code. So then I'm going to go back to our Anaconda prompt, and I'm going to paste that in there, and I'm going to run it, and it's going to install TQDM for us. So this should be pretty quick, hopefully. I'm going to put yes, let it do its thing. Okay, so it's done. So it installed TQDM. So go ahead and pause the video and go ahead and install TQDM for yourself. So once you have TQDM installed, go back into your Python script and here import TQDM. So TQDM is super easy to use, and the way you use it is all you have to do in your for loop is simply, so it says for shape in shape list. So before your shape list, before the thing that you're iterating through, you simply have to put TQDM and then some parentheses and put the thing that you're iterating through in parentheses. Oh, I apologize. It's another one of these from TQDM, import TQDM. There we go. Okay, so from TQDM, import TQDM, and then so TQDM, and then in parentheses you put your list. Put the thing that you want to iterate through inside the parentheses, and that's all you have to do. Like I said, it's super simple and it's super clean and super awesome. Watch. Boom. So as you see, it created a progress bar for us. So this was it's kind of a bad example. There's not many shapefiles in there, so it doesn't really, it might not even be necessary for this, but it shows you where it is in your iterations. So it automatically looks and says, hey, there's 3 items in our list. So we're on iteration 0 of 3, 1 of 3, 2 of 3, 3 of 3. It gives you a progress bar, and it even shows you, if this was longer, if you had hundreds or, thousands of items that you're iterating through, it'll tell you how many, on average, seconds per iteration. So in this case, we were roughly around 1 second per iteration. If you kind of look at these averages for each iteration. And then it'll tell you how much longer it thinks it'll take. Based on how many items are in your iterable, and then how fast it's currently iterating through. It'll kind of give you an estimated completion time. So it's a really cool tool, and really spiffies up your scripts and makes them more readable. So in that case, we know that this is working. We really don't need these print statements. That's kind of more, just to while we're creating the script, to make sure that it's working, and we printed out that it was doing, we printed out the projections just to make sure it was doing the right thing. But we really don't need those print statements. So let's try running this one more time and see what happens. Boom. So there you go. This is what you see. If you don't have print statements, it's a very clean progress bar that slowly fills up, and we were around 1 iteration again, or 1 second per iteration again, and it roughly took 3 seconds to do that. So yeah, that is all I have for you guys today. I know this was probably really long. I'm not even sure how long I'm at currently, but I hope this is helpful for some of you guys. I know when I first started out on my coding journey, to learn Python, I kind of was self-taught, and I learned a lot on the job, some really helpful coworkers, but I know it can be really difficult and really intimidating. But I've found just little projects like this, things that will make your life easier in your day-to-day job or just in your, side projects at home. Really getting your hands dirty. Like if you have something specific that you want to accomplish, if there's something, that you do every day, like this, like projecting a shapefile, instead of having to click 50 times through ArcMap or through QGIS, you can now, this script is a shape, it's a Python file. So all you have to do is take this script, and you can easily, send that to your work computer. Now you know how to set up a Python environment. You can set up your Python environment. You can install your packages that you need, and you can easily, run this to make your work life easier, your day-to-day easier, and things of that nature. I did show you guys, I might have closed it, but my GitHub account, where I have a number of scripts that I will also add this script on there, and I'll put a link to that in the in the description below. But yeah, so if you guys have any questions, please put them in the comments. I'm happy to interact with you guys, and hopefully I can, kind of my goal with this is to try to go through some Python stuff. Maybe I'll go through some of the other scripts that I have in my GitHub, just to walk through them. This one was really long with the setup and installation and kind of explaining stuff, but hopefully in the future they can be some shorter videos that might be able to just go into a specific script and kind of explain what's going on and how it works and what, the logic behind what I'm doing, and things of that nature. And hopefully they can be useful for you, in your learning path. So thanks everyone if you stuck around this long. Slow clap, but awesome job, and yeah, thank you. I'll talk to you guys next time.